All right, so our first polynomial division section is just going to be dividing a polynomial by a monomial. So this is kind of the first step towards using long division with these. We're going to be using this in long division, so it's really important that you get a pretty nice grasp on this before moving on to long division. And one thing we're going to be using is actually something we saw way back in chapter, not even chapter 1, it was that section R.1 on fractions. So if you remember, if you have two fractions, let's say a over c plus b over c, if they have the same denominator, we can go ahead and keep that common denominator and add the numerators together. In this case, they don't combine because they're not like terms, so we'll just put a plus b. Now what we're going to be doing is we're going to take something like this on the right, and we're going to be going backwards. So we're going to take a polynomial that's put over some single term, and we can split that up and then just keep the addition or subtraction in between. So let's take a look at some examples here. This first one I'm going to list out. I'm going to put some kind of terminology in this one and some notes, and then we'll go through some other examples. So with this one, we're given 12x squared plus 6x all over 6x. So this thing on the bottom is called the divisor. It's what we're dividing by. The thing on the top is called the dividend. And so what we're going to do here is we want to go ahead and split this up. And one important thing to note is that this only works when there's a single term on the bottom. If you have addition or subtraction down there, you have to use long division. All of these are going to use this kind of process though. So what we're going to do is I'm going to take the first term, this 12x squared, put it over the 6x, bring across whatever sign we have, so bring over this plus, and then we're going to put this 6x over the 6x. So if you notice, we just split this up. We took each of our terms on the top, made them into their own fractions with this divisor. And if we wanted to add these two together again, we still have a common denominator and we could bring it back here. So always double checking that you didn't change the denominator at all. And now we're going to use our quotient rule that we talked about back in 5.3, I believe it was. So we can divide. So 12 divided by 6 is 2. X squared divided by x. I'm going to do this with the canceling out method that I talked about. So I'm going to cancel out an x from the bottom and an x from the top. So we're left with a single x. The 6 and the 12, you can also reduce it down like this. So 1 and 2. That way is also super nice because they won't always divide completely. So you might be left with things on the bottom. We'll see some like that as we go through. Plus 6x divided by 6x, it's exactly the same, so it's a 1. And that's it. So we're just dividing by single terms for now. And let's go ahead and run through some more examples. All right, number 1, 6p to the 4th plus 18p to the 7th over 3p squared. So again, first thing I'm going to do is split this up. So we have 6p to the 4th over 3p squared plus 18p to the 7th over 3p squared. And now let's reduce or cancel. 6 over 3, I'm going to do this with the reducing. So this becomes a 1, this is a 2. With the p's, we can cancel 2 p's out. So we'll cancel out 2 from here, 2 from up here. And so on the top, we're left with a 2p squared. And the bottom is just a 1, so we don't care about that. Plus 18 over 3, we can reduce this to a 1 and a 6. We can cancel out 2 p's, so we're left with 5 on the top. So the bottom's just a 1, we don't care about that. And then on the top, we have 6p to the 5th. And they're not always going to end up in descending order like we saw before, because it didn't start in descending order. We started with p to the 4th and then p to the 7th. So your first one should have a lower exponent than the second one. Okay, let's try another one. Squeeze it in down here. 12m to the 6th plus 18m to the 5th plus 30m to the 4th, all over 6m squared. So at this point, we've done a couple. I would try this one by yourself. The only difference is there's 3 terms, which just means you're going to be doing the same thing just 3 times. So let's go ahead and try splitting this one up. So we have 12m to the 6th over 6m squared plus 18m to the 5th over 6m squared plus 30m to the 4th over 6m squared. All right, so now let's divide. This one I'll do with, yeah, I'll go ahead and reduce like we did up here. You can also just divide, so 12 divided by 6. Actually, I'll do that for this one. There are some others where they're not going to divide evenly. There are some examples like that that you can run into. They're not as common, but we will see one where that happens. For this one, I'll just cancel out the m's and I'll just divide the numbers. So 12 divided by 6 is 2. We can cancel out 2 m's, so we're left with m to the 4th. 18 divided by 6 is 3, so plus 3. Cancel out 2 m's, we're left with m cubed. Plus 30 divided by 6 is 5. Cancel out 2 m's, and we're left with an m squared. Okay, number 3. This one's written slightly differently, so we're just going to need to kind of rearrange it. So in parentheses, we're given 18r to the 7th minus 9r squared divided by, in parentheses, 3r. So I'm going to go ahead and actually just write this in the same format that we've been looking at in the previous examples. So 18r to the 7th minus 9r squared all over 3r. And then I'll go ahead and split this up. So we have 18r to the 7th over 3r. And now for this one, notice it's a minus. So we want to put minus 9r squared over 3r. All right, now let's divide. 18 divided by 3 is 6. And we can cancel out 1r, so we're left with r to the 6th. Minus 9 divided by 3 is 3. Cancel out 1r, so we're left with an r to the 1st, or just r. All right, number 4. 20x to the 4th minus 25x cubed plus 5x all over 5x squared. So this one is the first one where things aren't going to cancel out quite as nicely. So let's see what I mean. Let's go ahead and split this up first. 20x to the 4th over 5x squared minus 25x cubed over 5x squared plus 5x over 5x squared. So if we take a look at the first couple, these first couple of terms here are normal in comparison to what we've been looking at. So 20 divided by 5 is 4. We can cancel out 2 x's, so we're left with an x squared, minus 25 divided by 5 is 5. Cancel out 2 x's, and we're left with an x to the first, or just x. And then in this last term, 5 divided by 5 is 1, so those just cancel. And if you notice now, when we cancel out an x, we're left with an x on the bottom of the fraction. So we're going to put plus, and we want an x on the bottom of its own fraction. I can't just leave the top blank. So 5 divided by 5 gave us that 1, and we want to put that on the top. If we've gotten another number for, let's say this were 25 divided by 5, and we had a 5, that 5 would have gone on top. We'll see some like that, but just be careful when you're doing stuff like this. This is its own little fraction at the end. That x will never be under every single term, just that last one that had more x's on the bottom. So let's try another one like that. 50m to the 4th minus 30m cubed plus 20m all over 10m cubed. All right. So first things first, let's split this up. So we got 50m to the 4th over 10m cubed minus 30m cubed over 10m cubed plus 20m over 10m cubed. All right, so let's start dividing. 50 divided by 10 is 5, and we can cancel 3 m's, so we're left with just an m to the first, minus 30 divided by 10 is 3, and if you notice, all of these m's cancel out, so I'm not going to write any m's next to this 3 because there aren't any left. So then plus our last term, 20 divided by 10 is 2, and then if I cancel out some m's here, I can cancel 1 from the top and the bottom, and so we're left with an m squared on the bottom of this little fraction. So again, just on the bottom of its own fraction, not underneath the whole thing. Okay, this next one is kind of funky just because of the signs. So we're given negative 8p to the 4th minus 6p cubed minus 12p to the 5th all over negative 3p cubed. Okay, so if I go ahead and split this up, we're just going to have to be careful with the signs. So what I'm going to do is what I've been doing in the past up here. So whatever sign is in between is going to stay in between. But we do have a negative 3p cubed on the bottom, so that's going to go on the bottom of every fraction. So our first one, we have negative 8p to the 4th over negative 3p cubed minus 6p cubed over negative 3p cubed minus 12p to the 5th over negative 3p cubed. All right, so the weird thing about this one, when we get to these terms at the end here, let's actually we'll keep this. So our first term here, if you notice 8 and 3 don't divide evenly, all we can do there is cancel out these negatives. So negative over negative is a positive. So I'm going to make that a positive. And then we have to leave it as 8 over 3. And then we can cancel out 1p. We're left with 1 on top. So we have 8p over 3. Or you can write it as 8 over 3p minus, now this one is where it starts to get tricky with the signs. 6 divided by negative 3 is negative 2. But we don't really like to see this negative 2 here. So I'm going to write that down here. And then instead of writing a minus negative 2, I'm actually going to change that to a plus 2. So see how this negative and negative became a positive? You can do that if you have one out in front and a negative on the bottom, because remember, a negative in a fraction can go on the bottom, it could move up to the top, or it can go out in front. So putting that negative with the negative makes it a positive. And the p's completely cancel, so it's just a 2. And let's go ahead and do the same thing with this negative. So this negative we can think of as being on the bottom or on the top. You don't actually have to move this around in your notes if you don't want to, but a negative and a negative make a positive. So 12 divided by 3 is positive 4. And then we can cancel out 3 p's and we're left with a p squared on the top. So again, just be careful with those negatives. Yeah, just be careful when you have double negatives there. If it was a positive, it wouldn't have been a problem because we could have just put -2 and -4. But those double negatives kind of mess it up a little. Okay, let's go ahead and try 2 more. Number 7 is pretty similar to that one, or number 5 that we looked at. And then number 8 is going to be kind of more like a challenge type problem. So number 7, negative 9y to the 6th plus 8y to the 7th minus 11y minus 4 all over y squared. So let's split this up. We have negative 9y to the 6th over y squared plus 8y to the 7th over y squared minus 11y over y squared minus 4 over y squared. Okay, so first term here, we have a negative 9 on top, no number on the bottom to divide it with, so we're going to keep that negative 9. And then we can cancel out 2 y's, and we're left with y to the 4th. Plus, the same thing with the 8 here, it's going to stay. And we can cancel out 2 y's, so we're left with 5. So y to the 5th minus, on this one, we can't do anything with the 11, but when we cancel the y's, we're left with 1 y on the bottom. So we're left with 11 over y. Be really careful where that y ends up. Minus, there's nothing to cancel this 4 with, and there are no other y's to cancel out with this one. So there's actually nothing we can do here, but we do still have to bring it over as another term on the end. Okay, and then finally, this last one's just a little bit trickier because it has multiple variables in it, but it's actually not too bad. The division's pretty nice. So 45x to the 4th y cubed plus 30 x cubed y squared minus 60x squared y all over 15x squared y squared. So if you want to try this one, pause it and then check your answer. If you can do this one, then I would say you have a pretty good grasp on how to divide with monomials. The big thing with this one is remembering to divide like terms with like terms, or like parts with like parts. So x's with x's, y's with y's, numbers with numbers. But we do still have to split this one up first. So we have 45 x to the 4th y cubed over 15x squared y squared plus 30x cubed y squared over 15x squared y squared minus 60x squared y over 15x squared y squared. Okay, so let's go ahead and divide. So 45 divided by 15 is 3. We can cancel out 2 x's and we're left with 2 on the top. We can cancel out 2 y's and we're left with 1 on the top. So the bottom is completely gone. We have an x squared y on the top plus 30 divided by 15 is 2. We can cancel out 2 x's and we're left with 1 on top. And our y's completely cancel out. So we just have that x minus 60 divided by 15 is 4. The x's completely cancel out here. And we can cancel 1 y and we're left with 1 y on the bottom. So this is minus 4 over y. So again, be really careful where your variables end up. All right, so that one was just a bunch of examples just so we can kind of see how that works. Our next section is going to be the last one for chapter 5 before we get to factoring, and that's going to be the one with long division. So again, if you feel rusty with it, practice up on what it looks like just with regular numbers. We'll take a quick look at it, but then we're going to jump into doing long division with polynomials. So it's going to get kind of ugly, but it's just the same process over and over.